Let's now take a look at our example and let's graph our three-piece function from our previous problem. So f at x is 2x minus 1 if x is between 0 and 1, including 0, not including 1. It equals x squared on the domain between x equals 1 and x equals 2, and it equals x plus 2 for the x's that are bigger than 2. So again, our approach is to graph or think of each piece using only its domain. And often you may really want to do the table as I did in the previous example. So I'm going to do it on this particular one. And so I'm going to have three tables. My first table is going to use x's and y's from the first line. And so that's 2x minus 1. So if I substitute in 0, so I'd have 2 times 0 is 0, minus 1 is negative 1. I could pick 0.5. 2 times 0.5 is 1. 1 minus 1 is 0. Now, the problem I get into is you go, oh, wait a minute, can't use 0. Well, yes, or can't use 1, I should say. Yes, we can, but that's where our open circle is going to be. So what I'm going to do is I'm going to use 1. And 2 times 1 is 1, or excuse me, 2 times 1 is 2, minus 1 is 1. But remember, I can't equal that, so I'm going to use my open circle. So I'm going to put my little memory aid to help me remember it's an open circle. If I came down and graphed that, I would actually have the graph I have here, but I would have a closed circle at the point 0, negative 1, and an open circle at the point 1, 1. Do the same thing for y equals x squared for the second piece. There's my x and y. So I can use 1 and 2. I could use 1.5 if I wanted to. I think I will. So I have 1, 1.5, and 2. I need to square each of those. So that gives me 1, 2.25, and 4. And hopefully we'll recognize that's a parabola. So we know that we're going to be drawing a piece of the parabola. So I need to make this look at least a little bit curved where the previous piece was a line. So if I put those points on, there's my 1, comma 1, my 1.5, comma 2.25, and my 2, comma 4. Notice I have equality on both sides, so both of these are actually closed dots. And then my third piece, x and y, greater than 2. So I know numbers greater than 2 strictly would be things like 3, 4, 5, 6, 7. Remember, I'm going to actually use that endpoint. I'm going to use the 2. And when I plug that in, that gives me 4. But again, when I graph it, it's not an official point on the graph. It's going to come right up to that point. So I'm going to put an open circle. So I will use my memory aid of putting a circle around that to remind me that that's an open circle. And then I could have 3, and that's going to give me 5, and 4 would give me 6, and so on. If I wanted to, I could do, 2.001, and that's going to give me 4.001 to illustrate that it comes right into that particular point. So notice if I graph that, there's 2, 4, there's my 3, 5. This would actually, of course, continue going. This is the one piece that is actually goes on forever. It doesn't have a finite domain setup. Now remember, we don't actually equal the 0.24, so I would have an open circle. Now my final graph requires that I put all three of these together. Some of you will be more than comfortable just doing this all at one time in one graph. Some of you might like to do the separate graphs. So when I put this all together, you'll notice what actually happens here. I guess I enlarged my picture a little bit. That's okay. When I put this all together, this is what happens. Get back to where I was. There we go. This is what actually happens. Now notice, in this particular case, all three pieces actually match right up with one another. And so even though I may have had an open circle or two, because the two pieces match up and one of the endpoints was included, we don't need the open circles. And so this piece starts here, ends here. This is where the open circle might have been, but the second piece picked up with a closed circle. The closed circle takes precedence, goes over. We had a closed circle again. This had an open circle, but again, the closed circle takes precedence. And then this piece goes on forever. Remember, this one stopped, but this one would actually have the arrow on the end.